Hello viewers, welcome to my channel. I'm Hasham Ali Khan. Last video, 3 problems I have completed on inventory control. And we have seen how to calculate the EOQ, number of orders to be placed in a year, and what is the formula for reordering level, maximum level, minimum level, average stock level. All these things we have seen in the last video. Now in this video, 3 more problems I am going to explain. Every problem, 1 or 2 new points will be there. So you have to take a note of those new points. Always maintain running notes for my lectures. Then only you can be able to get a complete command on this topic of inventory control and stores management. So before starting the 4th problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Take the screenshot of the points, then I'll explain. Come on, see the 4th problem. A factory uses annually 24,000 units of raw material which cost rupees 125 per unit. Placing each order costs 25 rupees and carrying cost is 6% per year of the average inventory. Find out the economic ordering quantity EOQ as usual. How many orders are to be placed in a year? Already we have done. And what is the total inventory cost for the year, including the cost of material? This is the new point. First time we are going to learn how to calculate the total inventory cost, including material cost. Right? So first of all, apply the formula for EOQ. 2CO by I root. C stands for annual usage, annual requirement. It is given 24,000 units. And O stands for ordering cost per order. It is given as 25 rupees. And carrying cost is 6% of cost per unit. The cost per unit is 125. So 6% of 125, it comes to 7.5. So we got COI. Now simply you substitute in the formula 2 into 24,000 into 25 divided by 7.5 root 400 units. First question, we got the answer. The EOQ is 400 units. Number of orders to be placed in each year. The annual requirement divided by ordering quantity. Annually we require 24,000 units. And every time we place an order for 400 units. So 24,000 divided by 400. You will get 60 orders per year. Now third question, what is the total inventory cost for the year, including the cost of material? Now remember, 3 costs are there. One is material cost, the others are ordering cost and carrying cost. So total inventory cost consists of material cost, ordering cost and carrying cost. Separately we can calculate all the 3, or alternatively a shortcut formula is also there, that also I'll explain. First of all, we calculate individually what is the material cost here. Total inventory cost including material cost. The material cost is equal to, so per annum, how many units we require? 24,000. And what is the cost per unit? 125 rupees. 1 unit, 125 rupees is the cost. 24,000 units we require. So 24,000 into 125, 30 lakh rupees. This is the material cost. Now we need the ordering cost. Ordering cost per order cost is 25 rupees. How many orders we are placing in each year? Here we have calculated 60 orders. In 1 year, 60 orders we are placing. Each order costs 25. So 60 into 25, you will get 1,500 is the ordering cost. Now carrying cost. Carrying cost, the formula is average inventory into cost per unit into percentage of carrying cost. Average inventory into cost per unit into percentage of carrying cost. Now, average inventory. Average inventory means ordering quantity divided by 2. Formula you remember. Average inventory is equal to ordering quantity divided by 2. What is the average ordering quantity? 400. EOQ is the ordering quantity. The 400 divided by 2. This is the average inventory. The cost per unit is 125, that is given in the problem. Into percentage of carrying cost is 6%. So 400 divided by 2 into 125 into 6%, you will get 1500. The carrying cost is 1500, ordering cost is also 1500. The total inventory cost, material cost plus ordering cost plus carrying cost. Material cost 30 lakh, ordering cost 1500, carrying cost 1500. The 30 lakh 3000. This is the total inventory cost, including material cost. Right? Now, next one is fifth problem. See the fifth problem. A factory uses annually 24,000 units of raw material which cost rupee 1.25 per unit. Placing each order cost 25 rupees and carrying cost is 6% per year of the average inventory. Find out the EOQ and the total inventory cost including cost of material. Then secondly, the factory works for 320 days a year. If the procurement time is 10 days and safety stock 450 units, find the reorder point, minimum, maximum and average inventory. This is again a new point. First point, calculating EOQ and total inventory cost is same what we have done previous problem. But here the new information is given and different formula we have to calculate, apply for reorder point, maximum level, minimum level and reorder level, right? So first of all, we calculate the EOQ and the total inventory cost. EOQ 2CO by I. C, annual requirement 24,000 units. O, ordering cost per order 25. I, carrying cost per unit per annum. So 6% of 1.25. The cost per unit is given in the problem 1 rupee 25 paisa. 1.25 into 6%, 0.075. This is I. Now substitute 2 into 24,000 into 25 divided by 0.075 under root. So after root we are getting 4,000 units. So on the calculator, multiply 2 into 24,000 into 25 divided by 0.075 under root. After root 4,000. So EOQ we got 4,000 units. Now total inventory cost including material cost. So first we calculate material cost. How many units per annum? 24,000 units we require. Each unit the cost is 1.25. So 24,000 into 1.25, 30,000 rupees is the material cost. Now secondly we calculate ordering cost. Ordering cost, number of orders in a year into cost per order. The cost per order is given here 25 rupees. But number of orders in a year is not given. We have to calculate. Same formula. Annual requirement divided by ordering quantity. So annual requirement is 24,000 units and ordering quantity is 4,000. Just now we have calculated EOQ. EOQ we got 4,000. So 24,000 by 4,000 into cost per order is 25. Then multiply 24,000 divided by 4,000 will get 6. 6 into 25. 150 rupees is the ordering cost. Now we need carrying cost. Same formula. Average inventory into cost per unit into percentage of carrying cost. Average inventory into cost per unit into percentage of carrying cost. And average inventory is equal to ordering quantity divided by 2. The ordering quantity is the EOQ, 4,000 units. So 4,000 divided by 2 into cost per unit 1.25 into 6%. You will get 150. So total inventory cost, material cost plus ordering cost plus carrying cost. Material cost 30,000, ordering cost 150, carrying cost 150. So 30,300 is the total inventory cost including material cost. Now I will show you a shortcut method of calculating the total inventory cost. Instead of calculating separately material cost, ordering cost, carrying cost, in one formula itself we can calculate the total inventory cost. We'll get the same answer. Now see, alternatively, It can be calculated as follows. Total inventory cost is equal to MC. MC stands for material cost. Material cost plus 2COI under root. Multiply 2 into C into O into I root. Right? Where MC is equal to material cost. Material cost already we know 24,000 into 1.25, 30,000. Now total inventory cost will be MC 30,000 plus 2 into 24,000 into 25 into 0.075 under root. So 30,000 plus. If you multiply all the terms, you'll get 90,000. 90,000 under root, you'll get 300. So 30,000 plus 300, 30,300. Same value we got here also 30,300, here also 30. So whether you calculate separately or you calculate by simply shortcut method by using this formula, you will get the same answer. Total inventory cost. That's it. Now second part of the question says, the factory works for 320 days a year. In 1 year, working days 320 days. And if the procurement time is 10 days, procurement time means lead time. The time gap between placing the order and receiving the goods is 10 days. And the safety stock is 450 units. Find the reorder point, minimum, maximum and average inventory. First of all, the annual requirement is 24,000 units for 1 year. An year consists of how many working days? 320 working days. So we calculate what is the daily requirement or daily usage. So daily usage is equal to 24,000 units is the annual requirement and number of days 320. So per day, how much is the usage? 75. So 24,000 divided by 320, you will get 75 units is the consumption per day, daily. And consumption during lead time, procurement days is 10 days. When we place the order, it will take 10 days to receive the material. That 10 days is called lead time, procurement time. So how much is the consumption during lead time? Per day, 75 units. How many days? 10 days. 10 into 75, 750 units is the consumption required during lead time. And safety stock is given 450 units. Now remember the formula for reorder point. In this situation, reorder point is consumption during lead time plus safety stock. The consumption during lead time is 750 units and the safety stock is 450 units. So 750 plus 450, 1200 units is the reordering point or reorder level. Now minimum level. Minimum level is the safety stock level. Always we are keeping on hand safety stock. That safety stock is the minimum stock, 450 units. And maximum level is the ordering quantity plus safety stock. Ordering quantity means EOQ. How much EOQ? Already we have calculated 4,000 units. Here somewhere we have calculated EOQ 4,000 units. So ordering quantity plus safety stock. So 4,000 plus 450. 4,450 is the maximum stock level. And average stock level, minimum level plus half of reordering quantity. Minimum level is the safety stock level 450 plus half of reorder quantity. The reordering quantity is the EOQ 4,000. Half of 4,000 is 2,000. So 2,000 plus 450, 2,450 units. That is the average stock. So you have seen in this video, in these problems, every problem, 1 or 2 new points we are coming across. So don't ignore any problem. Watch all the problems from beginning till end and record all the points what I am explaining. Next, problem number 6. Sixth problem. A computer company sells a particular personal computer. It costs the store 25,000 rupees each time it places an order with the manufacturer. The ordering cost is 25,000 rupees per order and the annual carrying cost is 9,000. To carry one computer for 1 year, the carrying cost is 9,000. The manager estimates the annual demand of personal computers will be 1200 units. The annual usage annual requirement. Determine the optimal order quantity. Optimal order quantity means EOQ. And the total minimum inventory cost. In this problem, what is the material cost is not given. What is the actual cost of each computer is not given. So we cannot include the cost of computer. We need only variable cost. Variable cost consists of ordering cost and carrying cost. Right? Now, optimal order quantity, this is nothing but EOQ. EOQ 2CO by I under root C annual requirement 1200 computers and O ordering cost per order 25,000 rupees and carrying cost to carry one computer for 1 year it is 9,000 rupees. Now EOQ substitute 2 into 1200 into 25,000 divided by 9,000 and after root we are getting 81.65 and equivalent to 82 units. Therefore, optimal order size is 82 computers. So, whenever company wants to give the order, it should give the order 82 computers. In 1 year, the requirement is 1200 computers. Now, total minimum inventory cost, variable cost. Because we can calculate only ordering cost and carrying cost. We cannot calculate the cost of computer because the cost of each computer is not given. Right? The variable cost, the formula is 2COI under root. 2 into C into O into I under root. So 2 into 1200 into 25,000 into 9,000 root. So you will get 7,34,847. This is the minimum inventory cost, variable cost. So totally 6 problems I have completed on this inventory control and stores management. So if you are satisfied, give a like to the video, share my channel among your groups, among your friends, so that more students can watch the video and enhance the knowledge. Subscribe my channel if you have not yet subscribed. I have uploaded so many subjects videos. So visit the playlist, select your subject, watch the video, enhance the knowledge, get a command on the subject. So inshallah we'll continue the next problem in the next video.